Welcome. Here's our math stuff for today. So for those of you who missed 5th period and didn't have 7th period, so for those of you who didn't have that, here are the notes and me talking through all this stuff. So what we're going to be talking about this chapter, this is section 3.1, and we're going to be talking about polynomials. Polynomials. Cool. So then we can write any generic polynomial, it's a polynomial with respect to x, as some number, we'll call it a sub n, some number times some variable, we'll call it x, to the nth power, plus some other number times x to the 1 less power, plus some other number times x to the power below that. And then we go with the old plus dot dot dot, means we can go on as long as we want as well. And then we're going to end with a sub 0. There's some number that is sort of the end, and that doesn't have an x. That's just our number, our constant at the end. Okay? So the most important part of any polynomial is this part up here, this first thing where you have the biggest exponent. Regardless of where this thing actually lives in our polynomial, this is the biggest, the most important part. Okay, so there are some fancy names for a lot of the terms here. All right, so I'm going to go ahead and box this a sub n in this green. So a sub n is the leading coefficient. Leading coefficient. All right, that is a sub n. And then, so I'm going to go ahead and I'm going to put a blue bracket around this whole first term. So, this whole first term, a sub n times x to the nth power, is our leading term. I don't know why I decided to capitalize that T, just roll with it, okay? That's our leading term, all right? So if I say the words leading coefficient or leading term, and if I say leading coefficient, oh, okay, he's talking about the number attached to the x to the whatever power. If I say leading term, oh, I'm talking about the whole thing. Okay? So, the last thing we're going to talk about is I'm going to circle this guy in red, okay? Because that is our exponent. That biggest exponent is the degree of our polynomial. All right, so our polynomial is equal to the degree of this last number. Okay, a couple quick points about these things before we move on. These exponents should be whole numbers, so 0 or larger, and then these a's should be real numbers. These coefficients out front, these should be real numbers. Okay, if we have other weird things happening, we'll just ignore that. Hopefully, you won't do anything that'll get anywhere weird like that. Okay, so this a sub n term is the leading coefficient. This whole thing up front, this whole first term is our leading term, and then the biggest exponent is our degree of our polynomial. Okay, so moving on, let's have a little conversation about degrees. All right, I'm going to pause, write some stuff, and I'll be back. Alright, so if you're looking at a polynomial, and these are the powers of x, they can keep going, so we'll go ahead and throw a dot, dot, dot on there. Okay, we'll roll with it, pretend that it's straight. So these are powers of x, so if you see a term, or a polynomial, that has a biggest power of x that's a 0, well, that's a 0th degree polynomial. That is a 0th degree polynomial. If we see a power of x that is 1, that's a first degree polynomial. Power of x that's 2, and these are all the biggest exponents of our of the polynomials we're working with. All right. So whatever exponents show up, the biggest ones is our degree. All right. So the degree matches the largest power of x. Okay. All of these have fancy names that I'm going to expect you to remember. So if I ask you what degree is this equation, well, if you see that it has a power of x at 0, that's a constant equation, constant polynomial. That's constant. X equals 1, or x to the first power. What I would like for you to do is graph it, then pause this video, graph this, so y equals x, graph y equals x in your graphing calculator, and then come back. Well, imagine about what the picture looks like, what shape does it make, and then come back and we'll talk about what kind of graph this is. All right? Okay, welcome back. So hopefully you saw that y equals x makes a line, which is good because if we have x to the first power, we get a linear equation, a linear polynomial. All right? X squared, we worked a lot with these recently and we kept calling them quadratic. All right, so think quadratic formula, that sort of thing. These are quadratic equations. X to the third, when you raise something to the third power, you cube it, so this is called a cubic equation. X to the fourth, there are 4 quarters in a dollar, so that's a nice way to remember that 4 is quartic. And x to the fifth, the best way I know, because I'm a band nerd, is that there are 5 drums on a set of quints, so quintic. Alright, so these are our names. These are fancy names, powers of x and degrees. This is a good table for you to copy down. So if you want, pause the video and copy it. And then we will move on. Alright, so we want to do something called the leading term test. We want to graph these and we want to figure out what kind of equations we're working with. What's going to be happening with these. So our leading term test. This is going to look at that leading term, that biggest x value, that biggest x variable for our, that biggest exponent attached to a variable, to determine what's happening at the ends. So as x gets really, really big or x gets really, really small, what happens to the y part of our graph? Is it going up or going down, increasing or decreasing? All right. So what we're going to do for this, if we take a look at this function, f of x equals 2x plus 3x cubed minus 4x squared minus 6x to the fifth. Okay? What I want you to do is ask yourself this question and then pause the video. I want you to ask yourself, which of these is the leading term? What is the leading term and what should we be looking at? Check. So pause the video and write it on your paper. Ready? Pause. Okay, we're back. Here's hoping that you circled this one as our leading term because it has our largest exponent there. All right, so this guy is our leading term. If you'd like, you can actually rewrite this function as f of x equals negative 6x to the fifth plus 3x cubed minus 4x squared plus 2x. If you want to rewrite it so that way all of our exponents are going down, that's a great choice. That's a great way to make sure that you're always going to find this leading term. All right. So our leading term test is really concerned with the degree and the leading coefficient. Two things: degree and leading coefficient. All right. So we're concerned with the degree and the leading coefficient. Okay, so we have 2 options for our degree. Our degree can be either even or it can be odd. All right, so multiples of 2 and not multiples of 2, essentially. So we have even and odd degree, and then we have our leading coefficients can be either positive, or negative. All right, so we're going to take a look and see what happens to our graph when we have even and odd coefficients. What I would like for you to do are even and odd degrees and positive and negative coefficients. What I would like for you to do is look at even degree, so that maybe go like x squared. Right? So y equals x squared. Go to your calculator and graph it. Once you do that, I would like you to graph y equals x to the fourth, and then keep going, jumping by 2's, to see if you can come up with a pattern. All right? So I will pause the video, and you should too, and graph that. Right. Hopefully you discovered that after you graphed it, if you looked as x was getting really, really small, y was increasing. And if you looked at as x was getting really, really big, y was also increasing. Okay? So y was increasing and increasing. So what I want you to do now is take a look at those same even equation or degrees that we looked at, so 2, 4, 6, etc. And I want you to pause the video and graph the negative version, so negative x squared, negative x to the fourth, negative x to the sixth, and see if you can come up with a conclusion as to what is happening with our y's. So I'm going to pause, and you should too. All right, hopefully you discovered that as it gets really, really small, as x gets really, really small, the graph goes down, and as x gets really, really big, the graph goes not up, dummy, that was silly, down. So down and down. So if our graph is even, if our degree is even, excuse me, it goes up and up or down and down. Either way, it's going to go the same direction. So if you see an even exponent, and that's the biggest exponent in your graph, you can say at the ends of the graph, so as x gets really, really big or really, really small, it's going to go either up and up or down and down. All right, so now I want you to do the same thing, but with this time we're graphing odd equations. So start with like x equal or y equals x cubed, y equals x to the fifth. See what those look like. Graph it and pause your video. Alright, hopefully you discovered these are going down as x gets really, really small, and they're going up when x gets really, really big. Okay? So then, I want you to do the same thing like we did with the evens. So I want you to graph those same equations, so y equals x equals x cubed, y equals x to the fifth, but I want you to graph the negative ones. So make it negative x cubed, negative x to the fifth, and see what happens. Pause your video and go. Alright, welcome back. Here's hoping you discovered that they go up and down. So with an odd polynomial, an odd degree, your end behavior should be opposite. Whatever it's doing on the left is doing the opposite on the right. Whatever it's doing on the left is doing the opposite on the right. Okay? So, let's take a look at a few polynomials, and I need you to, once we take a look at them, you need to pause, figure out what the end behavior is for these, and then you need to, what's the end behavior for these? Duh. Okay. All right, I'm losing it. I'll write them all out, and then we can come back to it. All right, here are your functions. I want you to tell me what the end behavior is for each of them. F, G, and H. What is the end behavior for each of them? So I want you to pause the video and work through these, figure out what their end behavior is, and then come back to the video, and we will go through the answers. Ready? Go. And we're back. So here's hoping you looked at this and you saw, okay, positive leading coefficient, or even degree. So this one is going up and up. All right. For this g of x, hopefully you saw that our degree was 3 and our leading coefficient was negative. So this goes up as x gets negative and down as x gets positive. As x gets really, really positive and really, really negative. Okay? And hopefully for this last one, you saw that x to the sixth was actually our leading term because it had our biggest exponent, which was 6, not 3 or 5. So, and then this is negative. So if it's negative and even, then we can say that our end behavior is down and down. Okay? So, a couple more things and then we'll be all done. If I give you a polynomial, a function, we'll call it a polynomial with respect to x, and it's x cubed plus x squared minus 17 plus 15. Oops, 17x. What I want to ask you is, are any of these solutions? Is 2 a solution of this? Is 2 a 0? Or is negative 5 a 0? Are either of those working solutions? So how would you check that? Well, if we plug these in, if we plug these into our equation, they will be a zero. They will be a solution if. All right, so I forgot where we are, so I'm just going to say, do we want 2 or 5 to be, we want to find out if 2 or negative 5 are solutions for this. So what we do is we plug these bad boys right into our equation and see if we get 0 back. So let's plug in 2. So we go 2 cubed plus 2 squared minus 17 times 2 plus 15. So we simplify, get these to just some numbers. 8 plus 4, that's not a plus. 17 times 2 is, let's see, that's 20, 40, 38. 34 plus 15. So let's see. 8 plus 4 is 12 minus 34 plus 15. So 12 and 15 is let's see, that's 27 minus 34, and that is negative 7. So negative 7 does not equal 0. So 2 is not a solution of this is not a solution or a 0 of this polynomial. All right, so let's take 2 out of the equation because it doesn't work. Let's check negative 5. We'll see if negative 5 is a solution. All right, so we plug that in. So we say negative 5 cubed plus negative 5 squared minus 17 times negative 5 plus 15. All right, so negative 5 cubed is negative 125 plus negative 5 squared is 25, because negative times a negative is a positive. So negative minus 17 times negative 5, which is 85. So negative 85, so minus negative 85, plus 85 plus 15. So we say negative 125 plus 110 for these two, plus 15. This guy is 125. So negative 125 plus 125 is 0. Since that's a 0, 5 is a 0 or a solution of this polynomial. Okay? So these are all things I'll ask you to do on your homework tonight. I will also be making sure to copy, to take a picture and copy the book for you in case you forgot to take it with you. These will be due at the beginning of class tomorrow. It won't be super long, so enjoy your evening, and I'll see you tomorrow. Bye-bye.